Hi everyone, today we're going to be diving into something super exciting, robot trajectories. I'll be showing you how you can make and use your own paths for your robot. And let's get started. So what is a robot trajectory? Simply put, a trajectory is the path the robot follows, but it's a lot more than just driving from point A to point B. In both FRC and FTC, trajectory following is essential for any precise autonomous routine and can give you a huge competitive advantage. I've actually developed a library that helps you integrate trajectory following into your FTC robot. And throughout this video, I'm going to walk you through what a trajectory is, how it works, and how you can implement it. By the end of this video, you'll know how to create your own trajectory paths and tune them effectively to create smooth robot movement. Plus, I've also created a Jupyter Labs data visualizer that you can use to make tuning your robot a little bit easier. The first step to utilizing trajectory is understanding what a path and trajectory really are. A path is essentially a planned route that the robot takes, and once you've gotten that path inside your code, it's broken down into waypoints to create a trajectory. Each waypoint is assigned a timestamp which tells the robot where it should be at any given moment. If it's off, the robot adjusts and corrects itself to stay on course. These waypoints can be represented as pose 2D, which is simply the robot's position, X and Y, and angular heading, theta, at any given time. To know where a robot is at any moment, we need to use localization, specifically a pose estimator. Now I see a lot of teams who stick to odometry for their autonomous paths, but a pose estimator offers enhanced accuracy, allowing your robot to adjust to different field conditions more reliably. So whether your robot drives over a rough surface, collides with another robot, or drives over a game piece, it's better prepared to recover. But one huge benefit of using the pose estimator is that it can use cameras to integrate vision measurements. The Limelight 3A is one camera you can use, but other cameras like USB cams work too. These cameras help the robot detect fiducials, which are objects in the environment that the camera can recognize. In this case, they're April tags. In this year's game, Into the Deep, April tags are scattered around the field for fiducial detection. Each tag has a unique ID, which is then mapped into an FMAP file. And if you want to access it for this year, it can be found inside the Limelight documentation under Downloads. By recognizing these April tags, your robot knows exactly where it is in relation to them. And each time the robot sees one of these tags, it calculates the robot's current distance from the tag and estimates its pose 2D. This gives us an accurate reading of where the robot is on the field at that moment, and there's a lot more to camera and vision, but I'll cover it in a future video. Finally, let's talk about how the robot controls its movement during all of this, with something called the holonomic drive controller. The holonomic drive controller is a motion control system made up of 3 PID controllers, 2 standard PID controllers for the X and Y movements, and 1 profiled PID controller for the robot's heading or theta. The profiled PID controller lets the robot decouple rotation from movement in the X and Y directions, which gives it a smoother transition and better control. I've ported a lot of these functions over from the WPI lib docs for FTC Robotics, and if you want to dive deeper into these concepts, you can check them out here. I created an open source GitHub repository where you can access all the code I've used in this video. It's linked in the description below, and it contains everything you need to build an effective path follower. And I've also included a Jupyter Lab data visualizer to help with tuning your trajectory. The benefit of using this visualizer over the standard telemetry messages on your driver hub is that you can plot your data visually. This makes tuning your robot much easier and more precise, and it also allows you to save and share the logs. If you want to use the visualizer yourself, there's a separate video in the description that walks you through the download instructions. Hope you guys learned something in this video. If anything's ever unclear, just feel free to let me know. I'll walk you through it. But with that being said, good luck with your autos, and I'll see you guys next time.